Okay, so finding the final amount of a word problem in exponential growth or decay, we have some general information on exponential growth or decay or formulas when we're talking about that. So the first thing that we do want to look at is what formula we have. So amount, so final amount. Or the amount after a specific time is always going to be the whatever you put in. So I'm going to call P for put in or initial amount. And then it's always going to be 1 plus the rate and to the time. And the rate, we're going to look at what everything is. So final amount is your what you're talking. P, I always count that is my initial amount. Sometimes it'll be, if I'm talking interest, it'll be the principal. It is the what I put in. Okay, the rate, when we're talking about this, growth, you want the percent, move it to a decimal. And remember, when we're going from percent to a decimal, we move the decimal spot 2 spots. Decimal is always going to be smaller. 2 spaces. Now, if it's a growth, it's positive. A decay is going to be negative. The time is going to be whatever time frame that they're talking. So when we're talking growth and decay, it could be days, it could be hours, it could be anything that we're talking with that. If we're talking interest, usually it's an annual or a yearly when we're talking about that. So we're going to talk about that formula in a second. But for this problem, we're looking at how much we started with is 3,700. So we're going to change our problem. So we have 3,700 kilometers squared. So we're going to get sloppy and not put our units in there. We're looking for the final amount. Suppose that each year this area decreases by 7%. So my rate of change is going to be 1 minus 0.07. And what will the area be after 11 years? So each year it's decreasing, so those match the time frame. So it'll be to the 11th. I'm going to simplify this a little bit so that we can just type it into a calculator, because this is a calculator problem. I am not expecting you to multiply things times itself 11 times. So 3,700, and this is going to be 0.93 to the 11th. And like I said, I don't want you to have to multiply 0.93 times itself 11 times. So you are going to use a calculator. If we open up our calculator in our computer, make sure that you have it in scientific mode. I'm on a PC, so that's what I'm going to have. The Mac looks pretty similar, but a little bit different, so I'm scientific. And then I want to put this in exactly like I see it, but I'm going to actually do the order of operations myself, just to make sure that it's going correctly. So it's always parentheses first, which is why I got the 0.93. So 0.93 to the exponent button is x to the y in this case, or it could be an upside down caret. So to the, I've got my caret up in my typing, the 11th, and then I'm going to hit equals, and then I'm going to multiply it times my 3,700. No, I'm not going to. I'm going to go times 3,700 equals, and this should get smaller. It should be less than 3,000. When I do it, I didn't have all my stuff, so I've got to retype it. 393 to the 11th times 3,700 equals, and that will give me 1,665 and 0.38 if I was talking to the nearest thing, nearest hundredth. However, they're going to want it to the nearest whole number. They will tell you in the problem. So this is going to just be 1,665 kilometers squared after 11 years. All right, so this is a calculator problem, but it's making sure that you put everything in the correct spot and understanding how exponentials work. And then finding the final amount, it's the same problem. This time we're talking an interest rate. We're going to keep it a little simpler for this class. We're going to just talk annually compounded. Compounded means how often you're adding interest or looking at your stuff to put in more money or take more money out or charge more. And so it could be quarterly, it could be annually, it could be monthly, all of that stuff. So some of the basic ones I did have written down here. So compound interest formula is always the amount, the final amount that we're going to have equals the P, which is the principal, what you put in. And then it's 1 plus, because we're always going to be adding interest, whether, you know, it's a borrowed or whatever. So 1 plus the rate as a decimal divided by the number of times you're compounding it. And then your exponent is going to be your number of times compounding it times your years or whatever you're talking with the things. Usually with interest, we are talking years. You do want things to match up. Number of times per year that you're going to compound it, and the time would also match in the years. So when we're doing this problem, we are going to be plugging in our amount. We're looking for the final amount, so we need the A is our final answer. And what in this problem, we put in $4,700. Yet again, I'm going to get sloppy with the units. And then it's the 1 is part of the formula. It means I've got that whole amount, and I'm going to add interest, so every time that I'm looking at it. So it's always going to be 1 plus if it's growing, 1 minus if it is a decay, but with interest it's always a plus. And then this is my rate is 4% compounded annually, so my n is 1, meaning I don't need it. So this is going to be just 0.04. My n, yet again, this n and the n in the fraction are the same, and that is a 1, so 1 times 14 is just 14. I will simplify it before I get to my calculator. So this is going to be 4,700 times 1.04 to the 14th. And hopefully it's only 4% interest, so I'm not going to make a lot of money, but we're going to put this in the calculator. Yet again, my scientific calculator from my computer. I'm going to clear everything. So I'm going to go the 1.04 because I'm going to do the order of operations myself. To the 14th equals, and then I'm going to multiply it times my 4,700, and I get a grand total of $8,138.88 after 14 years, which doesn't really seem like that much, but I've doubled it. So my amount equals 8,138.88. And if they want it to the nearest dollar, this is just going to be $8,138. $39. I have to round up because that is closer to 39 than 38, so 39. All right, so these shouldn't be too bad. As you get into other classes, you will be dealing with other interest rates, other compounding along with it. So useful formula, good for plugging in values, and it's a calculator type problem. Yet again, show all your work, use the calculator as the last thing.